Welcome, my name is Carlos Askorski. I'm a product manager at Fireye. This video is to show you an introduction to commissioning the NXF4000. So let's get started by looking at the Fireye website at www.fireye.com. So this is the landing page for our website. We're going to go to the Products tab to start with, and then Burner Controls. And this page is going to show you our Flame Safeguard controls, and all the resources for these controls are available here. And also our efficiency controls, which are our Nexus products, and we're going to choose Nexus NXF4000 parallel positioning. So this is going to have all the documents and resources for the NXF4000. If we scroll down, the one you might use the most often are our product bulletins, which include the main bulletin for the NXF4000, servo installation, Modbus information, etc. We're going to go down to Service Guide for today's activity, and we're going to find the document NXF4000 Wiring Application Guide. So I'm going to open that. Now this is a document with some generic wiring diagrams for basic applications to help you get the wiring down and get started. Again, these are all generic, so your application might have some minor differences. So let's go from the top down. The first thing is the servos. Today we're going to be using two FX04 servos that are connected to the trainer. Each FX04 servo is 7.5 watt power requirement, and the NXF4000 can supply up to 60 watts of power, so we're covered there. We don't have to add an external power supply. But if you do need to exceed the 60 watt rating, all you need to do is add an external power supply. The NXF4000 also has 15 programmable digital inputs that can be used for different functions, and we're going to be using several of those in our application, and the setup for those is also described in this document. That matches the wiring diagram we're going to use, which is NXF4000-1. This is the wiring diagram that matches the NXF4000 trainer hardware as well. So let me go down to the wiring diagram itself. Now this shows all the basic wiring that we need to do, but I'm going to zoom in a little on the digital inputs that we're going to program. We have a burner on-off switch, which is going to go to digital input 1. Combustion air switch, which will go to digital inputs 7 and 8 for normally open and normally closed to do an airflow switch check. We have the proof of closure or fuel valve end switches, and those are going to go to digital input 15. Then we have the gas pressure switch for valve proving, which goes to digital inputs 10 and 11 for normally open and normally closed. Now let's go to the NXF4000 itself and get started on setting it up. So right now this is uncommissioned, and the first thing we're going to want to do is set up a profile. So we're going to set up profile number 1 for gas. So let me go push the down arrow until I get to the menu item profile setup. Now the part that you're going to select, and it's a little hard to see here, is the second line. There's 2 hash marks. Whatever's in between the 2 hash marks or on the second line is the item that you're choosing. So when I get to profile setup, I hit the next key forward. Now I make sure profile 1 is in between the hash marks, hit forward. So right now I have not been logged in. So if I hit modify save for profile name to change it, it's going to prompt me to enter a passcode. So I'm going to enter the C mode passcode, so I hit modify save, and this is 903. So I use the down arrow until I get 903. And then I hit modify save to enter it. Goes right back where I was, but now I can modify the profile name when I hit modify save. So I am going to choose gas and hit modify save. I'm going to leave all the other options default. We have max modulation 100%, min modulation 0. There's an option to erase the profile, and that's really all there is for profiles. So now that I've selected a name, I can continue setting it up. So now I hit the back arrow key, hit the back arrow key again, and now I'm going to set up the servos. Now these are connected via Modbus, and they're addressed 1 and 2, and the way you address them is with a little rotary dial with a screwdriver under the cover. There's a choice between 0 and 9, where 0 is 10, so 1 through 9 are addresses 1 through 9, and 0 is address 10. So you can have up to 10 servos. So I'm going to go up to Servo Setup. And the nice thing here is when I hit next, it's going to be able to find the connected servos for me. So servos installed 0. When I hit the next key, it will scan the network on Modbus and find them. So it's found 2. The first thing that I skipped over is the servo speed. We'll leave that at the default of 30. Servo 1 we are going to configure to be our air servo. So I hit next, hit modify save for the name, and then I go scroll until I find air. Okay, then I hit modify save. Now this is an important step. We have to pick an assignment. This means which profile will this apply to, and it can be multiple profiles. So you can pick 1, 1 and 2, 1 and 2 and 3, 1 and 2 and 3 and 4, or any combination you want. So we need to at least include 1, so we'll hit modify save, press up, and choose assignment 1 for profile 1. Now the direction is already corrected clockwise. If that was wrong, you could change it here. And this is the current servo position. So now servo 1 is set up. We hit the back arrow. Now we go to servo 2, and we hit next. And this is going to be gas. Hit modify save. And we scroll around until we find gas. And we hit modify save. We assign this to profile 1, modify save, hit the back arrow. Now we're going to use the VFD. And you can have up to 2 VFDs, and we're going to use 1 VFD for the combustion air blower. And we're going to hit next. So the VFD name, we'll choose fan, and hit modify save. Now we're going to get a couple of other choices. First is assignment, which is for the profile we want it to apply to, which is 1. Next, the display format. We're going to choose % of full speed. And something about the VFD is normally the VFD is going to get 4 to 20 milliamp feedback from the drive, and this is required so that we get feedback to know that it's doing what it's supposed to be doing. You can also use an encoder and connect an encoder instead of the 4 to 20. Now for the trainer, it has simulation in place to do that automatically. So we're going to choose % full speed, which will use 4 to 20 with the simulation of the trainer. So now we hit the back arrow and VFD is set up. So next we're going to set up a sensor. So we go down to sensor setup, hit the next key. We are going to leave it in English. The other choice is metric. So English is going to be PSI or degrees Fahrenheit, whereas metric would be bar or degrees Celsius. So we're going to hit next after sensor 1. So I'll go through the choices, but we're going to choose a steam today, but I'll show you the other choices as well. Hit modify save under type. First choice is track, and track modulation means to take an external 4 to 20, so to allow the modulation to be controlled by an external PID controller or a building automation system or a PLC. So an external source of 4 to 20. The next choice is we'll go to water. So if you hit modify save, it'll bring up a range option. So if you hit modify save, the first is 32 to 752 degrees Fahrenheit for high temperature applications, and the next is 32 to 350 degrees Fahrenheit for lower temperature applications. So I'll save that, but then when I go back to type and change it to steam, it will clear that out. Now I have to choose a steam range. So the first is 0 to 15 psi, low pressure steam, 0 to 30, 0 to 200, 0 to 300. And lastly, we have a negative 14.7 to 25. And this is a good one to use when you're using a low pressure steam system that might go into a vacuum. Because if you go below 0 and your milliamp signal drops below 4, you'll get an alarm. But with a negative 14.7 to 25, you won't have that problem. But right now we're going to use a 0 to 200. Hit modify save to apply that, and then go back. So now I'm going to enter a set point. So I hit the next key, set point 1 setup. So this is the set point 1, and it's going to use sensor 1. This is going to be our primary set point that we're trying to control. 2. I'm going to set that at 100. I'm going to leave all the other options the same, but cut in and cut out are the hysteresis points for where it'll turn on and off. So cut out being 3, and with a set point of 100, that means it'll turn off when the pressure goes above 103. With a cut in of 0, then when the pressure drops back down below 100, which is 100 plus 0, it'll turn back on. Then we also have the PID settings, which would be set from here, as well as an alarm for a high temperature or high pressure. So we hit the back key. and we go back to here. Now we're going to set up our digital inputs. So we get the digital input set up, hit the next key. So digital input 1 is going to be our burner control switch. So we hit modify save, and we hit down and get the burner control, hit modify save. Assignment is not applicable, it works on all profiles. And for an action we'd have to choose and or. And normally this means if you use the same action on multiple digital inputs, do you want them both to have to be on, or do you want either of them to be on, or any of them to be on? So if you had two digital inputs assigned to burner control and the action was and, they would both have to be on. If the action was or, either one of them could be on. We're going to use and because with the particular case of burner control, we also have the choice of using the burner control function off of the keypad, which is this button over here. So we're going to use and then we're going to set up the burner control button on the keypad as well. So that means both the keypad burner control and the digital input burner control will have to be on to turn on the unit. So now I'm going to go back. The next one we have to assign to match our wiring diagram is digital input 7. So then I hit next, and I'm going to assign this to be gas valve proving normally open. So I'm going to go the other way. I think it's closer to this direction. So GVP normally open. Okay, that's what I want. So I modify save. Now for this one I do have to choose an assignment. Which profiles does it apply to? So I'm going to choose 1. Then I hit back. Now digital input 8 we're going to set up for GVP normally closed. Hit modify save and choose profile 1. Now we hit back. Okay, now we're going to go to digital input 10. And this one is airflow normally open. Now this is definitely the other way, so I'll go back this way. And for this one we will also choose an assignment is not applicable. Action will choose and, because when it's the only input assigned to something, you can choose and or, and I'll typically leave it for as and. So now we'll go digital input 11, that's the next one, or hit next. Modify save, and we want airflow switch normally closed, and leave that for and, so hit the back arrow key. Now the last one is the fuel valve end switch or proof of closure, and that's digital input 15. So we'll hit modify save. And it's right there. And here for assignment we will choose 1. And we're done with that. Okay, so now we're going to go back. And the next thing we want to set up is the keypad, because, and that's down this way, because we want to use some of the buttons on the keypad as well. And by default they are set for unused. So under keypad setup, first is burner on key, which is this key up here. We are going to set that to used. And since we set up one of the digital inputs for burner control, they will both have to be on for the burner to start. The next is the auto manual key, which is right here. So to press this, it'll allow you to choose a manual firing rate. We want to be able to use that. So we'll hit modify save and used. Then we have the low fire key, which is right here. To press that, it automatically goes to low fire. So we want to use that. So I will set that to used. And the last one is the lead lag key. We'll leave that at unused since this is the only boiler we're setting up. So the last thing I have to set up here is for burner control. We want to set up a couple of options for the valve proving. So this is going to be where you would set up, next key. This is going to be where you would set up all of the timings, whether you want an interrupted pilot or an intermittent pilot, things like that. All the settings for the flame safeguard. So scroll down far enough and we will find the valve proving setup menu. So we'll hit the next key. So here you can set the test times and the method, and whether you want to test it pre-purge or post-purge. We will test it pre-purge, but the method we want to change from 2 valve to 3 valve normally open. And this is for a double block and bleed arrangement that would have a vent valve. So now we go back And we are ready to start commissioning. But before we do that, I'm going to go back to our website so we can look at a couple of other resources that we have there. Okay. So we're going to go back to the NXF4000 section and back to Service Guide. So the first is a document called The Importance of Proper Commissioning of a Parallel Positioning System. So we're just going to open this real quick and glance over it because it leads into our commissioning worksheet. But this is just a document that talks about why it's important to use good instrumentation while commissioning a parallel positioning system. And it is so that the PID control can work better. Because if your firing rate is linear, where 50% really does give you 50% of the output, the PID control, whatever it is going to be able to do a much better job of controlling the process. If you don't use any instrumentation and you don't know if 50% truly is half of the output, it's going to be hard for the PID to control to the set point. So this talks a little bit about that. So instrumentation, for example, would be to use a flow meter for the fuel. So you know exactly how much fuel there is at every firing rate, which makes it really easy to commission a burner. If you don't have a fuel flow meter, you can clock the meter at high fire and low fire. You can get the burner head pressure at high fire and put that into the worksheet, and it'll extrapolate head pressures at the other firing rates so that in the intermediary firing rates, at least you know that your gas is close to where it needs to be, because it's the gas servo position that dictates whether your commissioning is proper and true. So if you're going to clock the meter, you at least want to clock it at high fire so you know that you're at rate, and at low fire so that you know your turn down is accurate. And the burner head pressure in between can make sure you stay on track. Now to test the burner head pressure, the best way is to use a manometer to test at the burner head and reference it to the furnace pressure at the back of the boiler. So the document we want to use is the Nexus Commissioning Worksheet for gas fuels, and that is an Excel spreadsheet. I already have that open here, so we will work from this. So the first thing I would fill in is the site name, and we'll just put a test name, test site. Site unit number, we'll call it boiler 1. So if you want to put the Fireye serial number that is on the control, you can do that. We'll just put 1, 2, 3, 4, 5, 6. You could put the serial number of the boiler, whatever you want. It's your worksheet to fill out as you wish. So I'll put my name here. And the startup date today is April 14th, 2020. If you're watching this years from now, you'll know when we made this. Okay, so step 1 listed here is to check the servo addressing and direction. And we already just set up the servo, so we know that's okay. So step 2 is to set the servo standby positions. This is 0.0. This is when all the servos are in the closed position, or probably will be in the closed position. This is when the unit is idle. So we're going to go back and start the commissioning process, set the closed positions, and come back here and fill out those positions. Okay, so now we are ready to enter commissioning mode. So what we have to do is hit C mode. This is going to enter commissioning mode. Now, I'm still logged in from when I entered the passcode before. If I wasn't, it would ask me to enter the passcode 903 again. So the star P00 means that it is commissioning 0.0, which is the point when it is idle or in standby. So I use the down arrow key to go to air. I hit modify save, and it's already at 1 degree. So that's where I'd want to put it, so I don't have to modify anything. So I can save that position. Gas is also at 1. And you can't set the VFD at idle because it knows it's not running. So it actually won't even let you hit modify save. So now the burner is off. So I can hit next, but next would go to 0.1 normally, but since we're not turned on, in other words, our burner control switch is not on, it is going to go back to standby, ready to continue commissioning. So before we do that, let me go back to the worksheet so we can fill out the information for 0.0. We'll put 1, we'll put 1, we'll put 0. Now something I didn't mention is you can change the names of the servos for your particular application. So if this was LP, if I typed LP here, it would change throughout the document to LP for that servo. So I'm going to go back to gas. Or if you had FGR, you just type FGR here, and you did enter, and it would apply FGR for all of the positions in the worksheet. Now you can have up to 8 servos for this worksheet. I don't think you'll probably have 8 on your application, but you might have 3, 4, 5. So right now, 0.0, all the data has been entered. So step 3 is to set servo purge positions, which is 0.1. So this is for the purge. So let me go back to the NXF4000. Now I'm going to turn on the digital input for burner control switch, but I also have to turn on the burner on-off switch. Now it is going to be ready for me to enter 0.1. So it says star P01. That is for 0.1. So right now it's not running, so I can move the servo position directly where I want it to for air in VFD. I'm going to leave the gas at 1 for purge. There's no reason to open that. So I'm going to modify save, and I will set the air damper all the way up to 90 for the purge. So I just hold it down. So it'll take it a minute to get there. And it'll go right past 90, so see, it did. Once it gets going pretty fast. But it's not moving until you hit modify save. So right now I'm just setting it. So now it'll start driving towards 90, so now I can move it to the VFD, hit modify save, and I'll set the VFD up to, say, 80% for this. So the affinity laws are something that pertain to pumps and fans, and the affinity laws at according to the affinity laws, at 80% of the speed, we'll only use half of the power that we would use as opposed to 100%. So VFDs are a great way to save energy, save money, and usage. Okay, so I entered 80, it came back at 79.8, which is good enough. So before I enter that, I'm going to go back to the worksheet and enter these. So the position for the air was 90, gas is 1, VFD is 79.8, and the next step is to set the servo ignition positions, which is 0.02. This is where it will light off the pilot. So I'm going to go back to the NXF4000, and I have not committed 0.01 yet, so I hit next to do that and move it to 0.2. So right now what it's doing is it's actually purging before it moves to 0.2 for the purge duration of 20 seconds. And then you will hear the relays click, which are the there goes the commissioning position. So before the relays click, we actually have to set the positions. So I was a little hasty on saying that. So this is where we're going to set off the ignition position. Now the ignition position does not have to match low fire. It can be higher. So we will, let's say we're trying to figure out a good place for it to light off, and we're going to choose 40% for our air. And we'll choose 20% for our gas. So it's driving, and it has not opened the pilot valve yet, or ignited the pilot yet, because we have not committed the point. But once we do, then it will. So before we commit these, let's write it in our worksheet. So the air is 40, the gas is 20, and the VFD is 79.8, and we are ready to light off. And then, so let's do that. Let's go back to the NXF4000, let it light off. And you hear the relays click, which it would be the solenoids opening. And then once it's finished with the PTFI and the MTFI, the pilot and main flame establishing period, it will be at 0.03, which is low fire. And it'll start 0.3 from the ignition position. And from there we can go down or we can go up. So once the main flame establishing period is over, now we're ready to set up 0.3, and we are into commissioning the primary curve. So let's go back to our worksheet. So this is where the worksheet gets a little interesting. So 0.3, and this is step 5, we're going to drive the servos to the high fire position and set the gas input flow. So we are going to move the servos while at 0.3, which is normally low fire. We're going to move them all the way to the high fire position, including the air and the VFD, note the settings, and then you're going to clock the meter or be using your fuel flow meter to set the regulator to make sure that you can hit your high fire rate before we actually set low fire. So we're going to go to high fire, note down here in the worksheet what the settings are, make sure your rate is correct, and then actually set low fire. So I'm also going to real quick look at a picture of a burner nameplate. Now this is a little old, worn out burner nameplate, but we can still read it. So we just want to get the information off of this. And so here we have the rate, which is 9450 MBH, and that's the high fire rate. And 1520 is the low fire rate. So this will give us the turndown. I will use my calculator to figure out what that turndown is. And we also show a gas manifold pressure number, 3.28. We're going to put this in our worksheet, but normally we are going to actually measure the real burner head pressure at high fire after we clock the meter, and that's the number we'll put in the worksheet so that we can use real world numbers. But for the demonstration, we will just use this number and assume that it's going to be correct. So right here, rated burner output, we're going to put 9450, which is 9.45 million. We'll put that burner head pressure of 3.28. We will keep the heating value of 1050, which is your generic heating value if you don't know what it is for the natural gas. If you contact the gas utility wherever you're doing your startup and ask the heating value, you can be more accurate than that. So the turndown ratio is going to be the high fire divided by the low fire rates. So it's 9450 divided by 1520, which is 6.22 approximately. So I'm going to put that in here. And so that is going to, just move that, that is going to set all the approximate fuel flows for the points that we're striving to achieve. So we are going to ramp it up to high fire and look to set the gas regulator to achieve a rate of 9,000 cubic feet per hour. So that is if you clock the meter or are using a fuel flow meter. And this is what the burner head pressure should be at high fire, and at all of the positions below that. This is we're trying to set the gas servo so that at each respective point we get burner head pressure that matches this number. And we're going to trim the air and the VFD servos to have good combustion numbers, an O2 number that we want, CO numbers that we want, etc. So if we can put the boiler efficiency in as well, and let's say 82, should be typical for a steam boiler, something around there. It'll give us approximate output boiler horsepower as well. So right now what we're going to do is go back to the NXF4000 and ramp it up to high fire so that we can clock our meter and set our rate. So what you would do to be safe during an actual boiler startup is you'd go to the air and you'd bump this up a couple of degrees. Keep your eye on your analyzer, make sure everything's safe. You might be able to get 2-3 degrees out of it at a time. Apply it, move on to the gas, do the same. And you're always keeping your eye on your analyzer, of course, because now you have an actual live flame in the boiler and you can't go crazy. But remember, it doesn't apply it until you hit Modify Save. So we're going to do this with the fan as well. We're just going to keep going back and forth and wiggling it up. Okay, so now we'll get this up a little more. And we still have a ways to go. I'm probably moving the VFD up a little too fast, considering how much less room it has to go to be going full speed. So I'll speed it up a little for the sake of time for the video. When I do the other points, I will just assume you guys know to safely move each servo, and we're not going to be going as far either, but I'll just go the full range for all the other points. So again, this is the point for low fire, but I'm doing this just so that we can get up to where high fire would be, so that we can clock the meter, make sure that our regulator is set correctly, and that our high fire is proper. And then, so you have to make sure that you have a good load when you're doing this. Now I know it's not always easy to get a good load, but when you don't have a good load, it's never easy to set high fire, so that shouldn't be an excuse not to try to do it correctly. Save yourself a headache in the long run. So I'll just set the air up to 70 for high fire. Maybe a rough number because it would never be perfect in the real world, so let's just go 72. We'll say the gas got up to 50. Well, maybe we'll say 63. Okay. And then we'll have the VFD up at 95 at high fire. So I'm going to, now that I have all the settings at high fire, this is my high fire position. If I have a fuel flow meter, I'll know that I've hit my rate of 9,000. Or I'll clock the meter and make sure that my rate is 9,000 and make adjustments to the gas regulator until it is. When I'm satisfied, then I'm going to go back and look at the numbers, and I'm going to fill out those numbers here: 72, 63, and 95. And that is going to now give me target numbers for the rest of the positions by filling out the point 12 with those numbers. Now I'm going to go back to the NXF4000. And note that I'm still in the commissioning mode of point 3 because there's a star. I do not want to commit this point to memory. So now I have to work my way back down to the actual low fire position before I can save point 3. And that is the next step in the document, which is step 6. Set servo low fire positions. Now we're still on point 3. So now I'm going to go back down, and I'm just going to go back down all at once because for the sake of time. Now of course you couldn't do it this way. You'd have to work it back down. But let's say I'm going to go down to 30 for error. Our ignition point was 40, but your low fire can actually be lower than your ignition point, so I'll go to 30. Say it lights off a little better at a higher firing rate. And I'll set the gas at 15. I'll put the VFD back at 80 where it lit off. Leave that the same. And again, it's actually running right now, so I would have to go a lot slower than that. And let's set the VFD to 80. All right, so now let's write these numbers on the spreadsheet, and then we can commit 0.3. So the air is 30, the gas is 15, and the VFD is 79.8. All right, now we're ready to continue with the next points. So 0.4 is next. We have target numbers here in the red. And the target numbers are what we are guidelines to what we're shooting for. Now the most important one is the gas, because that is going to be, you're going to want to set your servo position of your gas to get this burner head pressure on your manometer. And that should be approximately 20.3. That's why these target numbers are here. We're going to pretty much just enter the target numbers during the exercise. But what you really want to do is make sure, number one, your gas matches your burner head reading on your manometer. And then you want to trim the air and the VFD close to the targets. But the primary purpose of those is to make sure that your O2 numbers are where you want them to be, such as 7% at low fire, 3% at high fire, or whatever you want them to be. So we're going to go back to the NXF and set up 0.4. So we have not committed 0.3 yet, so we will hit next to commit 0.3. Now it's going to go to 0.4, and so we can enter 0.4 information in. So according to the spreadsheet, we want 34.7 for the air. Again, for now, I'm going to just go all the way with each servo, and wouldn't be as big of a deal because we're not moving it as far, but you want to keep your eyes on the analyzer at all times when you're doing this to make sure you don't hit unsafe combustion numbers. 20.3 for the gas. And using the commissioning spreadsheet also takes the guesswork out of where you're trying to go, so you know where to set the VFD, because using the VFD in combination with the air can be a little tricky. You don't necessarily know which one to set. This just sets them both up linearly at the same time and gives you targets to shoot for. So then I've set those up according to the spreadsheet. Let's enter them in. So we put them right here. So our numbers are going to match 34.7, 20.3, and 81.3, so close. 50 is a little different. Now we're going to go to 0.5. So let me commit 0.4. Brings up 0.5. So it's going to be the same. So I'm going to enter 39.3. Shot right past it. Okay. And then for the gas, we want 25.7. And for the VFD, we want 83.2. So now let's enter those into our spreadsheet. So we got 39.3, 25.7, and 83. So now let's go back to the NXF and enter the next point. So I commit this by hitting next, and we go to 0.6. So 0.6 is going to be, the air is going to be 44. The gas, 31.0. Let's just say that's good. And the fan will be 84.9. So let's record those. .44, 31.2, and 84.7. And we're ready to go to the next point. So we'll hit next to commit 0.6, and we'll go to 0.7. So this time I'm going to start with the gas, and I'm going to go back to Spreadsheet just to remind of what we're trying to do here. We're trying to enter 36.3 as a target number to get a burner head of 0.93 on our manometer. So let's say I put 36.3 in. So I'm going to do that offline here, 36.3, real quick. But 36.3 doesn't quite get us the burner head pressure we're looking for. So we put it in as a target and we commit it, but now our burner head pressure is just a little low. It's 0.85. So what we want to do is increase that slightly to get 0.93. So go back to the NXF. So I had put 36.3 in, but now that wasn't quite enough, so I'll bump it up to 36.7, test it again, and now I got the burner head pressure I'm looking for. So now I set the air and the gas to get my O2 numbers where I want them to be, and following the target, that's going to be 48.7 for the air. And of course I'll check the analyzer, and I can trim this up or down as necessary to get my O2 numbers where I want them to be. Because the gas is going to be what sets the rate and how much power you get out of it. The air and the VFD are just going to give us good combustion numbers for the air-fuel ratio. So the VFD is 86.6. So we'll just get that close. And so those are the numbers that we've gotten for 0.7. So let's go back to the spreadsheet and put those in. So we have 48.7, 36.7, and 86.6. So now let's go to 0.08. So we'll commit 0.7, go to 0.8, and 0.8 our numbers are 53.3. And 41.7. And for the VFD, 88.2. So 0.8, let's record the numbers before we commit it. We got 53.3. .7 and 88. So now let's go back and work on the next point. So we hit next to commit 0.8, and now we're on to 0.9. So our first number is 58. Next we have 47 for the gas. And for the VFD, we're going to enter 89.9. So let's commit those to the spreadsheet. 58, 47, and 89.8. Okay, now let's go put the next point in. Getting close to the end. So let's commit point 9, and now we're on to point 10. So for point 10, we want an error of 62.7. Gas to be 52.3. Okay, let's apply that. And we want the fan to be 91.6. So we'll accept 91.7. And let's record those in the spreadsheet. So we got 62.7, 52.3, and 91.6. Let's move on to the next point, and getting real close to done, which is great. So let's commit point 10. Next point is 11. For the error, we're going to shoot for 67.3. Gas of 57.7. And an error of 93.3. So point 11, let's record the points on the spreadsheet. $67.3, 57.7, and 93.2. Okay, now we've gotten all of the intermediate points in, and we're back to point 12, which is the high fire point. These numbers are the same numbers that we already recorded earlier from over here when we ramped it up to high fire while actually at point 3 when we were clocking the meter. So let's go back to the NXF4000. So we will commit point 11 to go into point 12. Now all we're going to do is simply put those numbers that we recorded when we went to high fire at point 3 back in to the control. So let's set the air first, 72. And these numbers should still be good because we clocked the meter with this gas setting. So if you are going to make any changes, don't change the gas servo setting because you know you're at your rate there, but you could tweak the air in the VFD to change your combustion number slightly. That won't affect your output because you'll still have the proper gas rate. But just make sure that you don't substantially change the gas rate or you'd want to clock your meter again and make sure you're still within where you're supposed to be. Make sure you're delivering the right amount of output. And then this is 90, should be 95. So all the points are in for point 12. Now a big difference here, since this is the last point, is that we do not want to hit next because you can put up to 24 total points or 20 programmed points in. So we could actually have a lot more than this. But this is enough to make a good curve and an accurate curve. That's why the worksheet is limited to these 12. But when we're finished, we actually want to hit C mode to exit the commissioning mode. And it will go straight into auto and modulating at this point. So we're completely finished commissioning it. and it is now running in auto, trying to maintain the set point of 100. So if we scroll down, we can see that the modulation rate is 41%. If we lower the value, it will increase. But we are in full modulation now on the curve. So the last thing I want to do is save the configuration I've set up to an SD card. So as soon as I pop in the SD card into the slot, it will bring up the menu for the SD card. So I will hit SD card ops setup, hit next. I want to back this up, so I will back up. Oh, it's not in standby, so I got to turn it off. So I'll hit back, hit home. I'll actually pop the SD card back out. I'm going to turn it off using the burner on off button. Let it post purge. And then when I pop the SD card back in, it'll go right back to the proper spot on the menu. And I'll hit next. I'll go back up. And I will back up profiles and parameters. And it is not logged in anymore, so I have to enter the C mode passcode. So I want to hit modify save, put 903 back in. Hit modify save. Profiles parameters next, and it is in progress, and it has saved it. So now I could eject the SD card, put it into another unit. So if I had multiple units on the same job site, it would make it a lot easier to do the commissioning. So let me go back to the spreadsheet. So now that we are finished with this, we could enter notes, we could save it. If you go to print this, it actually prints into 2 pages with the borders shown in between the gray borders, so it makes 2 nice pages that you can save, print it out, save it as a PDF for your records. And that's really all there is to setting it up. So I hope you guys found that informative, and I'd like to say thank you for watching and have a nice day.